Hi, in this one I'm just going to go over the drawings real quick, kind of point out a few things. It's really just a big ridge skylight. I don't think it's too complicated. There's some gaps for thermal expansion. The hard part's just setting the elevation and the locations of the posts. We did that elsewhere. Here's our half plan of the barcode sheet. I didn't mention it in the other video, but this code A12 should be A10. I've marked it up in a bunch of sheets, but it's hard to get them all. And it's A10 is that little code right there. Once you know that, you'll be in pretty good shape. Otherwise, you'll be looking for it and never find it. So here's the drawings, and I'm just going to kind of walk through the drawings one by one. The glass has a frit on it, and they run in a certain direction. Uh, Unfortunately, the glass lights are perfectly square. So you could put the frit lines in the wrong way, or you could vary them and make like a weird checkerboard. Be very careful with the frit lines. I'll come back to this on the plan view, but the frit lines all run one way. That's up and down the slope, and then I'll show you the plan. I got it marked in as well. The glazing strip, we had the painter pull it. They didn't want to because it's not standard strip. Um, it's got a little extension to catch the sealant when you do the inner sealant joint. That extension should point to the center of the bar. The grooves should be on the outside, the plain part to the middle. I can show you that better on this model. Um, so you're going to see some strips where this smooth pointy part is on the outside. You'll need to pull them out and just slip them back in the other way. Be the right length, you can just pull it and slide it. But they should always look, no matter which bar, the smooth stuff points to the middle. That's our typical rafter. This is our little middle rafter, the infill guy. Same thing. They point to the inside. The gutters are free. The grooves are on the outside. And if I'm not giving you seizures with all that flipping around, there's the crossbar. And that has similar stuff. The smooth part to the middle, and the grooves go there. The crossbar is not symmetrical. It only goes one way with the gutter uphill. It's a little weird, but don't lose track of that. I forgot all about it till just now. So the crossbars have to go, and they would actually install the wrong way. So you want these always on the bottom edge of the glass, the high side of the crossbar. So be careful when you're putting them in. You could flip them, and there's nothing that would stop you from getting it wrong. Did not think of that till just now, but yep. And in some places, this notch leaves room for the bar to slide a bit. Not there necessarily, but in other places. So that's important to note. If you look at this, this is the low end of the skylight. Gutters going to the upslope, gutter to the upslope, gutter to the upslope. And then the rafter bars are symmetrical left and right, but the miter cut on them, let's just do it that way, is odd. We kind of skewed it so that it the crossbar, the clip screws wouldn't be on the splice joint, which would give you the option to slide a bar in afterwards once you put this in. It would be a tight fit, but you sort of had the option to have the clips there to hold the gusset and then slide the rafter to it. The crossbars where they hit these rafters at the notches are all drop-in, so you can leave them out till you get the rafters done. Let me get rid of a few other parts here, and then as long as we're on the model. Why can't I delete anything? So we notch this to make the splice between the bars, because I do need to carry water as a backup in case the caulk would leak. And we've got a piece of Dow 123 tape in here. So you're going to have to cut it for one dimension. It's just a little bit shy one way, but the other way it comes in a roll. You just cut a strip off. And you're going to want to seal it to both pockets. So you're going to want to put a full bead in here so it's stuck on there for a good long time. And then the movement between the bars will just happen in the stretch of the Dow 123. It's such a shallow pitch. We weren't sure about anything else. We didn't think we can get a piece of metal to fit in here. So it's Dow 123 gets put into that pocket and sealed on both sides. And that hopefully will bridge the water across to give us some kind of backup to help out with drainage. Another thing I thought of just yesterday is we did not do anything for temp capping the glass when you put it down. And I wasn't sure what to do, but my thought is at the ridge line, take the glass stop and cut it in half. And then take the glass stop below. So the one you cut in half, put half the length in, and then take the one below and after you put it in there, and then just slide it across the groove into the next bar up. Because it's sitting in the serration and above the rubber that makes the splice, it can go right through this joint. And then because you've got a half cut up here, that'll leave a gap to get a screw in. And I thought if we end up with a gap at the middle of each bar, that would let us put a retainer that kind of crosses a bunch of lights with a screw in that one spot and another screw here. And then you can sort of get a temp cap going on 3 or 4 lights at a time. That's a thought. We should probably talk about it, and we'll come back to it a little bit later. But there is no way to temp cap it on here because it's a fin, or here because it's also a fin. And we didn't want to drill holes in it because that would be a point that would defeat the drainage system. So all I can come up with is either cut the glass stops, all of them in half and make all little pieces, or just cut the top 20 in half and just slide everything up half a bay, which I thought would work out pretty good. So before you do it, I'll send you a sketch. We should talk and maybe think it through. I've just been doing that off the top of my head. It might be cut a quarter would be the way to go. And put 3/4 in and slide it up a quarter. And then just take the quarter length and use it down at the curb where the panel is. So we'll have to see. Like I said, the crossbars all are notched so that they can drop in. So they've got this clip, and the clip is reversed with a hole in it and the screw runs through, so you can use a pretty long H2. And then the bar is notched and there's this bottom cap, and that will make it so you can drop all of these guys in. And then these infill bars are cut with a notch to overlap the crossbar on the downhill side only. On this side, the high side, they're flush with the crossbar. So I think what we thought was tapped clip on the end here, so that would be over here. Put the channel clip on the other side of the bar and put the screw on. Then catch this guy over the channel clip, and he's got a tapped one in, and then slide him down onto the crossbar. Or you may have to take these two together and hook it there, and then hook them and slide them down on that one. But if you need to reverse it, you can, and you can play games with the clips till you find one that lets you get what you want to do. I think once this bar's on the clip, you could probably work it high enough up to get this one to go in and go over the clip, but you know, that sometimes goes. Try one out and see how it works. They were getting them together in the floor, but I don't know that we looked at it for that specific thing at that time. Um, so that's something just to keep in mind as you build from the ridge down. How do you want to sequence this? And I'll come back to that in the drawings again as well. Um, these are the posts. There may be notes about a bolt being in here. That turned out to be too expensive, and I thought probably not that workable for you. So we didn't do it. You're going to have a stack of shims that goes in here instead. And I think that will work out pretty good. If you need to, just get a pry bar and lift it up and knock them out. But the shim lets it bear on something while the welder puts these plates and gets it tacked. And then you tap them out with a hammer and you're good. You don't have to have anything under it. He's got a lot of vertical welds to make this whole thing weld tight to this beam. The beams are very thick, 2 1/8. You wouldn't want to be drilling and tapping, and there's so much adjustment to happen. Shimming and drills, it just didn't seem like it was going to work. So we've been working hard to make it work with the welded connection, get a welder, get the painter line up so all this stuff can work. If there's any questions, give me a call. We'll talk it through. We'll figure out what we got to do to make it go. But I've done all I could think of to get it doable at this point. So I'm going to get rid of my model here. And then we will look at them on kind of a paper version. So the frit, the glazing strip, watch your caulk for metal to metal joints. I have to check this to make sure we're okay. They may have changed these colors. Let me, before you caulk any panels, make sure I have confirmed that color to you. I'm just looking at it going, did I forget to check that? Everything else is black, but the metal to metal, I want to double check. So here's the direction of the frit lines, which, where's my zoom up command? Directional lines. So you want all the lines to be going up with the slope. This is our pitch, 6 on 12. That should be pretty easy to keep an eye on. Towards the end, we have testing. We've got these guys hired, and they got to do a chamber test. We marked it in one spot, but really the architect is going to pick one random, and then they're going to do a full chamber test to, pressure differential, trying to push water through it, so make sure it's caulked good so it passes the test. Because then they're going to start asking to make sure that they know that everything is perfect, and they have to provide the water and get it up there for the lab. They weren't aware of the platform, but the platform will work for them to get in and test things, so that should be okay. The crossbars, when you do the layout, the shoulder was a certain offset from the center line. That's because the bottom center of the crossbar is aligned with the 11-foot grid. So it's a little bit offset, but only at the top. The bottom is what's supposed to line up. It's platform, the pitch. There ain't too much to go over there. Here you can see where it's tap clip and clearance hole clip. So tap, tap, clearance, and then tap. So we weren't sure if hooking it and it would drop in by itself, or if you had to play with the crossbar at the same time, or if it would be better to go the other way. All of these are crossbars, and then the infill goes between them. You have enough clips that you can reverse it and do clearance where the T is and tap where the C is if that works better. We made enough so that it worked either way. The camber I went on to no end before. Alignment with the holes we went through. The internal sunshade is going to come after us, so you don't have to worry about that blocking your access. These are the panels at the corner. We sort of made a little relief so the panel could run by without having to jog around us. You might want to point that out when they come to field measure the panels. That's something I forgot to tell you about. Let's go back here. Let's go to page 4. So we've got a panel here and here at each jam, and then there's another panel company that has to make a panel with a tapered bottom to match us. So when our frame is locked in, we want to let them know so they can come and measure things. This end of the beam does not move very much under camber, so they can come and measure and hopefully install their panel before you put this light of glass in so they can work through that hole. But this is the least moving part for deflection, so that shouldn't be a problem. As you build the frame, it probably would make sense to put this panel in so they can just measure straight to the panel and make their panel fit it just perfect. When you're ready for that, let Vaughn or myself know, and then we'll contact. If I do it, I'll tell Vaughn so they can contact the panel guy. If you tell Vaughn, they should be able to get the panel guy out there. They also have panels at the curb, and once you have the little tray in here down, they could come and measure to that tray as well. Again, that's not going to change very much for the camber because this beam I don't think is moving. It does have some movements potentially of a 1/4 inch, 3/8. It's kind of up in the air. But we should talk about it because they're waiting to measure all that perimeter until our frame is in so they guarantee the fit. The other thing we didn't talk about is when we do the camber, this camber's the full amount, all these beams do the full amount, and then the curb does half of an amount. And it also has a post here and here, which may limit it to like 1/8 of an inch of movement. In which case we're going to be about a 1/4 inch high from where we should be at the curb. They did not answer if that support is going to lock it down tight. I'll try again on Monday or Tuesday to see if I can get that information because we may want to adjust our heights that we're using for the preset along the curbs at 3 and 6.3. But other than that, we're trying to build a crown, and as it loads, it's going to flatten out. In my opinion, better we should shoot a little high, and we end up with keeping a little bit of the crown in the skylight rather than having it go low. We're not talking numbers that it's going to be hard for the glass to accommodate it, but there's definitely a crown going across. And it's all the same because these beams are all going to bend the same. They all see the same amount of load, except for the 2 outside ones where that's less. And potentially I could see the curb being high after we're all said and done. I don't know that a 1/4 inch is going to upset anybody, but something to wonder about. Here's the model with that. That's the steel with the posts. We went over that. Here are the details we just looked at in the model. You got the clips with the bottom plate that's painted. The crossbars drop in. The dowel 1, 2, 3 sealed both ends. Here's our clip, how it goes in. It's still a serrated hole, but you can use a longer screw and push it through. So it's got this blind clip. Don't forget the slip pad between the steel support and the skylight rafter. And then the bolts that tap into here should get Loctite, just so they can't vibrate loose. And then we'll go from there. Wouldn't overdo the Loctite, follow what it says on the bottle. If we get in trouble and we should have to raise something, this is the place where we'd want to fix it. We'd want to bring some kind of bottle jack, a hydraulic little jack, and jack the frame up and try to slip a shim in here if we had to. God help, I hope that doesn't happen, but that's the emergency backup plan, is to shim at that spot if something goes bad. So Yeah, we need to Loctite on the threads, but I don't want it to lock too tight, shall we say. Just don't need it to fall out 5 years from now. This is the curb. The sunshade guy has a clash with us. They should be handling that. We made Vaughn aware of it months ago, so that should work out. This is the tray that you're going to attach to the frame after you get your frame up. And then that just seals to the frame. We offset the splices so that you'd have access to do the splice joint. It's a catch pan to take any drainage from the system and weep it out. And the panel by others comes up underneath there. There's a blow up of that same detail. The rafter has a little tongue, it drains out, comes out the weep. Your panels should fit over here. Older drawings had some plastic, which we didn't buy. So the insulation goes continuous over the top. These flashings should be sealed, or we have some flashing tape that you could tape the joint with. Probably a bead of sealant's good enough, and back it with the batting. We want to make it airtight and just a good insulated cavity. This is a typical crossbar, one with the support and one without. Note there are no caps. The job is all structurally glazed, all on the inboard light. So on the inboard lights, you got a 1/2 inch deep caulk joint. You just pump it in for the laminate. Hopefully that's close enough that the sealant will catch there. On these bigger gaps where it might, the tolerance will probably eat that up. But the hope was to get it more like this so the sealant wouldn't need a backer rod below it. But that's the idea of the funny glazing strip, just to not have a backer rod to deal with. When these joints go in, they need contact with the air for a week or two to cure. You can't put the weather seals on over the top right away. You've got to let them cure for a bit. And then we also, during that curing period, we need to do some kind of temp capping, which I hadn't really thought of until just yesterday. So that'll be kind of a fix here at the end. The fix for the temp cap is going to be based on these glass stops here, the 17s. There's only 20 of them. And if we cut a quarter off one length, then we can slide everything up 2'9" and leave a space for a screw. And then with that, then we can get some longer retainers and then bolt those down to temp the glass in. And I think that's probably going to be the easiest way to do everything. But it doesn't show up in the drawings because I didn't think of it until just recently. So where were we? Yeah, so that's the crossbar. The bottom of the splice has a slot. There's supposed to be a gap. And then the structural joint, there's a gap here to let the bar kind of ride up and down against this one. That's why this bigger caulk joint is in here. It's tolerance in some places, other places it's to allow the expansion to happen without tearing the sealant joint. So they expand upward at each one. So make sure you keep your gaps, kind of monitor your gaps, or you're going to come short at the end of the job. So if your posts are located, the gap should just manage itself if your posts are all done per your layout on 11-foot centers. At the ridge, it's a little funny because we got two rafters expanding at each other. And what we did is the bolts here at the channel clip go through holes in the rafter but slots in the splice plate. And then these two bolts have a slot in the rafter but screws in tapped to the splice plate. And what that's going to do is it's going to allow the rafter and crossbar to move towards the center without binding up on the splice plate. It's kind of complicated, but it's also sitting on the plate with the screws here. Before you get started, check a couple of these posts to see if they're fitting in the tapped holes right. I could not do that. They came in too late. Everything was done. The slot should give us some tolerance as well as the expansion. But do check it. It's the only thing I could not check before it shipped. You got an inner flashing that lays on the main rafters and just runs the 11 feet to the next. And then you've got a panel that goes over as well. And then there should be a caulk joint in between. So I don't think there's anything here that's too new. Oh, that's that. This is our intermediate. Tap clip up here, clearance clip there. You can see the notch that's going to drain into the crossbar. Again, the gutter for the crossbar uphill. This is the intermediate rafter. Nothing too interesting there. That's the ridge where the intermediates come in. These are the rafter sections. You can see here's the slide in. We need to make a gap so that we can run a retainer kind of this way and then screw it down into the gap between these slide-ins. And I think that will work. Here's our slip pad crosshatch. This is the steel post, the screw with the Loctite. Channel clips, truss heads. There's the little Dowel 123 splice where that's milled out at the joint. And this is a crossbar where there is no panel and the crossbar just drops in. I did not draw any sealant where the crossbar drops over the rafter. It would not hurt to put a little bead of sealant on the crossbar as you drop it in. I didn't want to lock that in for some consultant to nitpick at us about. But I think you should do it. I think you should put a little bead of caulk on the bar just so that it can't backtrack underneath and leak. Don't need any drip. It's a little bit of a pain, but I don't think it'll kill anything. So the plan of the post. These are some connection details. Nothing too spectacular. This is the end rafter, and our panel just goes up and goes here, and we put a little bit of shim to the sheathing. If we have trouble with tolerance here, the answer will be to cut this leg off, and we'll ship you a new angle, and we'll put the bolt in on top. We're hoping it's going to fit close enough. There wasn't a whole lot to go on. Center of post to face of sheathing should be 11 1/4. Something to keep an eye on. Here's the post. That's the sunshade kind of drawn in for reference. This other cladding isn't by us. This panel's not by us. They're going to field measure that. This is our little inside. So we got a piece with a hem that comes over. You're going to want to set it in sealant and pop rivet it here or tape it. You know, we want to make a nice insulated cavity. Their waterproofing above the sheathing needs to go out and exit there. We do not want this waterproofing to come into that inner flashing. These gutters can't handle any kind of drainage that would come from there. So watch that they don't waterproof it down here and think we're somehow magically going to drain it. That's how these guys think. It's not what our stuff does. Waterproofing has to exit above the glass. There's a detail of it. Here's the waterproofing going over the top. We got returns on the panels, you can see there. The glass joints don't match the return exactly, but that should be known. Caulk joint to the glass. You're going to be doing the 1/2 inch joint all around every light, then let it cure, then do your weather seals. This is a plan at the corner. We made this little pocket so that the panel guy didn't have to work around us. And let me go back to the curb, because he may have questions about this when he's field measuring, and if you could take a minute and talk to him, you could see here's the end rafter, our panel, coming down and going like this. And then the wall panel by the other panel guy can come and he can go straight by, and these are his curbs. So we have a little relief that just kind of gives him that little 1 inch, 1.5, whatever it is. So his panel will run through, and then the caulk can kind of fit in there where I left the hole. You'll see it when you have the parts. It's hard to see on paper. There's an inner tray. We want to make sure we seal that to all the frames so it's watertight and can fill up full if it needs to. So water's going to come down the rafter, spill in, but we don't want it leaking at the end plates or where the rafters overlap or where it's up against the curb bar. Um, just pump it. You can't have enough caulk. Just keep caulking it. And these are the steel parts. You have all that. We did check the layouts for the hole in the slot to make sure they would be they're to the right design. It's just to make sure that the steel guy drilled them exactly as we showed him here. So, and I suppose that we drilled them the right way too, but they were in the model the right way when the CNC program was written. I think that's it. I'm sure I missed things. Read all the notes. It's hard to give you every bit of information up front. I'm just trying to get you a good start. Please read it, counting on your craftsmanship and your attention to detail to follow through and kind of make it go. I'm not always thinking all install. There's a lot of other things to answer. So call me if you need me, and talk to you soon. Bye.